Okay, so this video we're going to be calculating some trig tables, and this means we're going to want to be finding values where the trigonometric functions sine, cosine and tan equal at these angles 30 degrees, 45 degrees and 60 degrees. So to do this we're going to be constructing some right angle triangles and then finding, just calculating the exact values for sine, cosine and tan just from the lengths of the triangles. So firstly, we can construct a triangle that has both 30 degrees and 60 degrees at the same time. So we can do both of these first. So let me just sketch out this triangle. We're going to be considering this equilateral triangle where every side has length 2. So this is 2, and the base is 2. So we know since it's an equilateral triangle, all the angles are, they have 60 degrees, right? Because the angles in a triangle add up to 180 degrees. So this gives us the angle of 60 degrees, but to use the definitions of sine, cosine and tangent, we need a right angle triangle. So what I'm going to do is I'm going to drop down vertical line down here so that it is perpendicular to the baseline. So this is 90 degrees. So we've essentially chopped this angle in two. So instead of 60 degrees, we have 30 degrees. And that's how we get the second angle. So 30 degrees, 60 degrees, and this is 90 degrees. So now we're just going to be considering this triangle actually. So we have this length 2. This side is half of 2, so I can rub this out and just say this side length is 1 between here and here. And then we also need to work out the vertical height. So we can do this just using Pythagoras' theorem, and we have, so this length is going to be this squared minus this squared, and take the square root of that. So if I write this as x, then x equals the square root, 2 squared minus 1 squared, just because 2 is the hypotenuse. And then we can evaluate this. This is 4 minus 1, which is the square root of 3. So x equals the square root of 3. Now let's think about evaluating sine, cosine and tan at these angles. So we can start off with sine of 30 degrees. And we know that sine is kind of the ratio of the opposite side with the hypotenuse. So we just need to identify what the opposite and the hypotenuse side are. So if we're looking at this angle here, 30 degrees, the opposite side is this one, which is 1, and the hypotenuse is 2. So this tells us immediately that sine of 30 degrees is just a half, which is actually a really nice quantity. So we can do a similar thing for cosine. Cosine of 30, this is defined as the adjacent over the hypotenuse. And here the adjacent side is just x, which we calculated as the square root of 3. And again, the hypotenuse is 2. So this tells us that cosine of 30 degrees is just the square root of 3 divided by 2. And then finally for tan of 30, this is the ratio of the opposite side divided by the adjacent side. And it's actually the ratio between these two quantities. But let's look at the triangle. Opposite side is 1, and the adjacent side is x. So this is 1 over root 3. And we can actually simplify this just by multiplying top and bottom by root 3. To get this to be the square root of 3 divided by 3. So that's all the trig values evaluated at 30 degrees. Let's do a similar thing for 60 degrees because we have this triangle already that has 60 degrees in it. So let's start off with sine 60 degrees, then by definition opposite divided by hypotenuse. So here if we're looking at this angle, opposite is the x value, which is the square root of 3, and the hypotenuse is 2. So it's square root of 3 divided by 2. Then we can do cosine of 60. This is the adjacent divided by the hypotenuse, so 1 divided by 2. And notice here that these are kind of similar to these values. In fact, we've actually swapped the values of sine and cosine here. So sine of 30 is a half, and here cosine of 60 is a half. Cosine of 30 is the square root of 3 over 2, and sine of 60 is the square root of 3 over 2. So this is kind of a nice pattern that it might help you remember. We're going to talk a bit more about at the end when we've got all the values calculated. But finally, let's look at tan of 60. Tan of 60 is the opposite divided by the adjacent. So opposite is x, adjacent is 1. So square root of 3 divided by 1, which is just the square root of 3. So we're 2/3 of the way there. We've got just 45 degrees left. And to do this, we need a new triangle actually, because we can't really get 45 degrees from this triangle. So I'm just going to sketch out a new triangle and then we'll calculate these values. So if we want to find 45 degrees, we can actually draw an isosceles triangle. So I'm just going to sketch this triangle out where this length and this length have the same length, and they make 90 degrees here. So if I just say this is length 1 for simplicity, then this is also length 1. And then since these lengths are the same, these two angles are going to be the same as well. And since the angles in a triangle add up to 180 degrees, this forces these two angles to be 45 and 45 degrees. So this is how we get the 45, and then to work out these ratios, we need the lengths of all the sides. So let's just use Pythagoras to work out the longest side. And this is just going to be, if I label this x again, then by Pythagoras, this is the hypotenuse, so it's the square root 1 squared plus 1 squared. And then obviously this is just the square root of 2. So now we've got these values, let's evaluate these trig functions. So sine of 45 degrees, this is the opposite divided by the hypotenuse. So it doesn't actually matter which angle we look at, but let's look at this one here. Then the opposite to this one is 1, and the hypotenuse is x. So it's actually 1 over root 2. And we can simplify this by multiplying top and bottom by the square root of 2. So we get square root of 2 divided by 2. So let's do cosine of 45 degrees. This is, well, now this is defined as the adjacent divided by the hypotenuse. But the adjacent is actually the same as the opposite, so it's 1 over root 2 again. So in fact, these two functions have the same value at 45 degrees, which is, as we said, is the square root of 2 over 2. Finally, we want tan of 45 degrees. So this time it's opposite divided by adjacent, sorry. So 1 divided by 1. So this is just 1, which is really nice. So we've calculated all these trig values, and these are really important because it's really good to know these functions add a few values. They always seem to come up. But now let's talk about how you remember this. So you could either not remember and just learn how to derive them. So just draw these two triangles and calculate it. Or you can look for patterns in these values. So what I want to point out is if we look at just sine first, we have a half, root 2 over 2, and then root 3 over 2. If we look at cosine, but let's look in the backwards order, so if we look at 60, 45, 30, then we have a half, root 2 over 2, and root 3 over 2. These are the same values of sine, just in the reverse order. So I'll just say that again, a half, root 2 over 2, root 3 over 2, a half, root 2 over 2, root 3 over 2. So in fact, you can actually just remember half of these values, just a half, root 2 over 2, root 3 over 2, and then remember that sine and cosine, for these values, they go the other way. And that's just because of the shape of sine and cosine, they're the same graph, they're just shifted slightly. And then tangent's slightly different, so this is root 3 over 2, this is 1, and this is root 3. But it's kind of always using the same numbers, so 1, 2, and 3, and then we have these square roots. So another way you could remember these, this isn't a pattern I use, but lots of people find this helpful, is that we remember that square root of 1 is just 1. So we have square root of 1 divided by 2. And then if we look at sine, we have square root of 1 divided by 2, square root of 2 divided by 2, square root of 3 divided by 2. So we have another pattern which maybe it might be helpful to you to remember. So we just have the square roots of the numbers going up by 1, 1, 2, 3, and we always divide this by 2. And as we said before, cosine is the same, just going the other way. So I hope you now understand how to calculate these values, and hopefully some tricks to remember them, because these are really useful.